Hello everyone, Assalamualaikum warahmatullahi wabarakatuh, and good day to every one of you. So welcome to my video. So basically this video is a continuation video on the chapter 3, which is induction machines. Okay, so this is my name, Dr. Norzulali binti Muhammad, and here is my email address. So you can just feel free to email me whenever you have a question regarding the content of this video. Okay, alright, so in this topic we are going to continue our lesson on the equivalent circuit model of the induction machine. Okay, so in the previous video you had learned on the topology of the equivalent circuit model for the induction machine, where it has a rotor pipe and also a stator pipe. Okay, and then you also had learned on the various equations that corresponds to the equivalent circuit model for the induction machine. Okay, so in this video we are going to see the various equivalent circuit configuration for the induction machine. Okay, so this is the equivalent circuit configuration that you learned in the previous model, where here you have a stator circuit and here is your rotor circuit. Okay, however, this equivalent circuit is not convenient for predicting the performance of the induction machines due to its complexity. Okay, so it's very hard to do the analysis on this type of circuit. So that's why several simplified versions have been proposed in order to simplify our analysis and also our calculation. Okay, so there are several simplified versions, which is the first one is we name it as a approximate equivalent circuit. Okay, so for the approximate equivalent circuit, what happened is magnetizing branch, okay, this is the magnetizing branch, can be moved to the machine terminal, and then we remove the RC. Okay, so here the magnetizing branch we move to the machine terminal, which is here. Okay, and then after that we remove the RC. So how the approximate equivalent circuit looks like, it's just like this. Okay, okay, so this is how it looks like. This is the original circuit. Okay, so this is the how the approximate equivalent circuit of the induction machine looks like. Okay, you bring the magnetizing branch to the terminal, okay, to the primary side. Okay, and then we just remove the RC. Alright, okay. Okay, so the next simplified version, we name it as a IEEE recommended equivalent circuit. Okay, so what happened for this version, the magnetizing branch retained at its place. Okay, so we just leave it there, but we remove the RC. Okay, we just remove the RC and then we just leave the magnetizing branch at its original place. Okay, so how it looks like, it's just like this. Okay, this is the original equivalent circuit configuration that we learned in the previous video. Okay, and then this is the IEEE equivalent circuit for the induction machine. Okay, you see here you just remove the RC. Okay, alright, and then next, the third version, we name it as a Turbine equivalent circuit. Okay, so for the Turbine equivalent circuit, what happened is for the V1, R1, X1 and also XM, we replace by the V Turbine and also R Turbine. Okay, and then RC also we remove. Okay, so how it looks like, it's just like this. Okay, so this is the original circuit. Okay, and then this is the Turbine equivalent circuit. Okay, here your RC you just remove, your XM, X1 and also R1 you will replace it with the R Turbine and also X Turbine. Okay, and then for V1 you replace with V Turbine. Okay, for the R2 prime over S and also JX2 prime, you just leave it there. Okay, so this is the equivalent circuit of the Turbine. This is the circuit for the Turbine equivalent circuit for the induction machine. Alright. Okay, so for this is basically the summarization of all the various equivalent circuits. So this is the original one. So this is the approximate equivalent circuit where you remove the magnetizing branch to the front side. Okay, and then here is the IEEE equivalent circuit where you just remain the original location of the magnetizing branch, but you remove the RC. Okay, for the Turbine equivalent circuit, we replace R1, X1 and also XM with the value of R Turbine and also X Turbine. Okay, V1 we replace with V Turbine. Alright. Okay, here and also the I2 prime will remain at its original place. Alright, okay. So for the Turbine equivalent circuit, so basically again for the Turbine equivalent circuit, we replace the R1, V1, okay, your X1 and also your XM is replaced by the V-Thevenin and also the R-Thevenin. But how to calculate the V-Thevenin and R-Thevenin actually? Okay, so how do you calculate? So basically, what happened? We just remove the rotor circuit here. Okay, you just remove here, you remove the rotor circuit, and then you just leave it with the stator circuit. Okay, so, and then in order to find your Z-Thevenin, you just short circuit your V supply. Here is your input voltage to the stator part, and then you just short circuit here. Okay, short circuit here, remove the rotor circuit, then you find the Z equivalent at this point. Okay, the Z equivalent is equal to the Z-Thevenin. Okay, Z equivalent at this point is equal to R1 and also JX1 is series, and then both this reactance and also resistance is parallel to the JXM. So that's why you come up with this kind of formula. Alright, so how to calculate the V-Thevenin? Okay, so basically, still you need to remove the rotor circuit. Okay, you remove, and then you put back the V supply here. Okay, so the V-Thevenin is actually the open circuit at this, the voltage across this open terminal. Okay, so how to calculate the V-Thevenin? You can just apply your voltage divider rule, where your V-Thevenin will be equal to your value of your V supply, which is your V phase, multiplied with your, because the V-Thevenin is the voltage across the JXM, so that's why V-Thevenin is equal to JXM divided by R1 plus JX1 plus JXM. Okay, so this is the formula that come out from the voltage divider rule. Okay, so you can just further simplify your V-Thevenin. In order to find the magnitude of the V-Thevenin, you can just use this formula. Alright, so basically this is the formula to find the amplitude or the magnitude of the V-Thevenin. Alright. So next in this circuit, we will show you the summarization of the equation that related to the Thevenin equivalent circuit. So basically this is a equivalent circuit, the Thevenin equivalent circuit for the induction machine. Okay, you have a V supply, you replace with the V-Thevenin. Okay, and then you no longer have a R1, XM, and also X1. Just leave with R-Thevenin and also JX-Thevenin. Okay, and then you put back your rotor circuit. Okay, so your current that go to the rotor circuit is I2 prime. Okay, so here is the reactance and also resistance at the rotor part. Okay, alright. So basically this is a formula that you can use to find the V-Thevenin and also the Z-Thevenin. Okay, so this formula is actually similar to the one that we showed in the previous slide. Alright. And then you can further simplify your equation. Okay, so these two equations can be further simplified by assuming, let's say, if your XM is much greater than your X1, okay, and then your XM is much greater than your R1, so you can further simplify this equation that will be equal to V-Thevenin is equal to XM divided by X1 plus XM multiplied with your V1. V1 is the V supply to the stator circuit. Okay, and then for the Z-Thevenin, if your XM is much larger than your X1, okay, XM much larger than your X1, then you can cancel this thing, and then here also, you can cancel this thing, and then you can also cancel these two, and then your XM plus X1 is much greater than your R1, so that's why you can just cancel your R1. So finally, you can further simplify your equation so that your R-Thevenin will be equal to XM divided by X1 plus XM squared multiplied with R1. Okay, and then your X-Thevenin will be equal to your X1. Alright, so this is basically comes from these two equations, but in the simplified version. Alright, so for the I2 prime, which is for this circuit, I1 will be equal to your I2 prime. Okay, so in order to find the I2 prime, you just apply the Ohm's law, where the I2 prime will be equal to the V supply, which is the V-Thevenin here, divided by the equivalent impedance. So the equivalent impedance R-Thevenin plus your R2 prime S squared plus X-Thevenin plus your X2 prime squared, and then you put the square root. Alright, so this is the formula for the I2 prime for the Thevenin equivalent circuit. Okay, so later on, we'll be using all this formula in order to do the analysis on the performance characteristic for the induction machine. Okay, so that's all for now. we will see in details on how to use all the formula in the next following video, where we are going to do some analysis on the induction machine. Okay, and then that's all for now. I see you in my next video. Okay, bye.